Hi everybody, we're going to continue our lesson on graphs. So this is a lesson, so just like in class, I do expect you to take notes on this. So if you have a printed out copy of the blank note sheet, that would be very helpful. Otherwise, go ahead and take notes. You can pause the video to catch up on notes if you need to. In addition to that, just like in class, I'm going to be asking questions throughout this. So I do want you to think about that. So when I ask a question, probably pause the video, give it some thought, get your answer, and then play it and see if we agree on that. Okay, so here we go. Let's get started. We're going to look at this velocity time graph for a car. So think about what's going on in this graph. All right, my first question is, when is the car moving in the positive direction? So here's where you can pause, think about it, and then replay. Okay, so it's very easy in a velocity time graph to tell when it's moving in which direction. The direction of velocity is the direction of motion. So whenever the velocity is positive, you know you're moving in the positive direction. So that would be 10 to 40 seconds, that whole interval there. Next question, when is the car moving in the negative direction? Well, similar to positive, whenever the velocity is negative, it's moving in the negative direction. So we've got two intervals here. 0 to 10 seconds and 50 to 60 seconds. And then, of course, 40 to 50 seconds, the velocity is 0, so the car is not moving in 40 to 50 seconds. Okay, so let's see what we can get from this. We're given a velocity graph, and of course you can get velocity at a certain time, but we can also get how far the car goes. Okay, remember our equation, velocity equals displacement divided by time. So we've got velocity information in our graph and time information in our graph. So we should be able to get displacement for each interval. Just solve that equation for displacement. So let's look in the first interval, 0 to 10 seconds. Okay, our velocity is negative 10 meters per second and our time is 10 seconds. So we should be able to multiply that out and get negative 100 meters. Now our next interval, 10 to 30 seconds. Okay, our velocity is 10 meters per second. Our time interval is 20 seconds. So our displacement for that interval is 200 meters in the positive direction. Next interval, we've got 20 meters per second for 10 seconds. So there we get another 200 meters in the positive direction. 40 to 50 seconds, well, we're not moving, so we don't have any displacement in that interval. And then 50 to 60 seconds, we've got negative 10 meters per second for 10 seconds, so negative 100 meters in that interval. Now remember, these are displacements just for that interval. So that alone does not tell us how far we went. We have to do a little bit more for that. So first, let's create a position time graph from this. So we need to remember all these values. Okay. All right. So in that first 10 seconds, we had a displacement of negative 100 meters. Now we're assuming the car starts at position 0. If we did not assume that, we wouldn't know where to start the position graph. But assuming the car starts at position 0, the first 10 seconds, we have a displacement of negative 100 meters. All right. Now from 10 to 30 seconds, we have a displacement of positive 200 meters in the positive direction. So we have to start where we left off. So we're at position negative 100 meters right now. And then our displacement for this interval is a plus 200 meters. So we end up at the position of 100 meters after this interval. Our next interval, 30 to 40 seconds, we have a displacement of positive 200 meters. Our next interval, we have no displacement. That's when we weren't moving, we had no velocity. And then finally, 50 to 60 seconds, we have a displacement as negative 100 meters. So there we go. So our final position after all this is positive 200 meters. Okay, we are just moving back and forth. Remember, this is one dimensional, so think a number line. So what's the distance we traveled here? Now we can get that. Okay, pause, give that a thought. Okay, so the distance, we start at 0, we go 100, and then 200, and then another 200, and then another 100. So if you add all that up, we should get 600 meters on that. And then the next question, displacement. Okay, for displacement, our final position is right here, 200. Our initial position is 0, so our displacement is plus 200 meters on that. Okay, and here are the two graphs together just so you can see the relationship here. All right, so we've got the position graph, which we created, the velocity graph, which we were given. And remember, we created that position graph by taking the velocity times time. So that first interval, we took a velocity of negative 10 meters per second and then multiplied that by 10 seconds. The second interval, we had a velocity of positive 10 meters per second. Then we multiplied that by 20 seconds. Next interval, we had a positive 20 meters per second times 10 seconds. Okay. Next interval, we had nothing. And then the last interval, we had negative 10 meters per second times 10 seconds. This looks familiar. Okay. What are we doing here? When we're taking like this 10 seconds times the negative 10, or this 20 seconds times the 10, what are we doing there? Yeah, we're taking base times height, right? So really when we're doing that, we're getting the area of each of these sections. Okay, that's the exact same thing. So a lot like the position graph, when we did displacement over time, we saw, oh, that is the same thing as the slope. Same thing we have here. When we're doing the velocity times time on the velocity graph, that ends up, we're just taking the area between the line and the x-axis. So let's take a look at this. All right, so the same graph. Okay, now for this one, you can, you should write some things down here, and I'll show you here in a second. But the area of a rectangle, base times height. So that first interval, 0 to 10 seconds, we've got a base of 10 seconds, a height of negative 10 meters per second. So our area, again, look at the units. I mean, they work out to be meters when we're just thinking about area here. Okay, so in your notes, you should probably shade in these areas just so you recognize what area we're looking at. But area, you've done that before a lot in math class. So the next one, 10 to 30 seconds, just the base is 20, the height is 10. Next one, the base is 10, the height is 20. Next one, we have nothing. And then the final one, our base is 10, our height is negative 10. Okay, so if you look at the areas there, they are identical to the displacements we found a couple slides ago. And of course they are. We're doing exactly the same thing. The math is all the same. Okay, so yeah, the area between the velocity curve and the x-axis is equal to displacement. Okay, and it's important to say between the curve or the line and the x-axis. You don't want to go all the way up to the top of the graph or all the way to the bottom of the graph. That wouldn't make sense. So it's always to the x-axis. All right, another velocity time graph for a car. So I'm going to ask you questions on this. So here are your 3 questions. So why don't you pause, get some answers for all 3 of these, and then we'll talk about it. Okay, so when is it moving in the positive direction? This is tricky. You have to be thinking. You have to remind yourself all the time what kind of graph you're looking at. You're looking at a velocity time graph, okay? Because a lot of students see, oh, it goes up, that's when it's moving positive, down negative. That's not the case with the velocity graph, though, okay? So remember, the direction you're moving is always the direction of the velocity. So when I look at this graph, the velocity is always positive, therefore, we're always moving in the positive direction, which means negative direction, we're not moving in the negative direction at all, okay? And when are we not moving? Never. I mean, you could say the instant at time 0 and the instant at time 60, but that would be it. There's no interval where we're not moving. So think about what this car is doing. It's starting from rest, and then it speeds up to 30 meters per second. It maintains that 30 meters per second, slows down a little bit to 20, keeps that for a while, and then slows down to a stop. Never in this graph did the car go in the other direction. Okay, so these graphs, I can't emphasize this enough. Always, always, always look at the axes. Remind yourself what kind of graph you're looking at. All right, one more here. Here's a velocity time graph. Okay, so I'm going to have the same questions here. Okay, so pause, give this a thought. Okay, so when is it moving in the positive direction? Whenever the velocity is positive, so that's 0 to 20 seconds. When is it moving in the negative direction? Whenever the velocity is negative, that's 20 to 60 seconds. When is it not moving? Only at that instant of 20 seconds. That's when it's changing direction. So the car is going 20 meters per second, slows down, stops just for an instant, and then starts speeding up in the other direction. Whether the car actually turns around or goes in reverse, we don't really care. It's not relevant to our discussion. Okay, now, how far is the car going 0 to 60? I don't know. What's the displacement? I don't know. Okay, so let's take a look at those, because these are things we can solve for. We do have those equations, because whenever you see a slope on a velocity graph, you know the velocity is changing, you have acceleration. If you have acceleration, we've got 4 equations that cover us for acceleration. So let's look at one that we can use in this situation. And that's this one. Displacement equals basically average velocity times time. Okay, and we get average velocity, we just take 1/2 times the initial plus the final velocity. So let's go through this for each of these intervals. So the first interval, our initial velocity is 20, our final velocity is 20, and I'm looking, just here, 0 to 10 seconds. And then our time interval is 10 seconds, so we get a displacement of plus 200 meters. Next interval, I've got us going 10 to 20 seconds. Okay, so our initial velocity is 20, our final velocity is 0, interval is 10, we get plus 100 meters. Now the next interval we should know should be a negative displacement, right? Because we're moving in the negative direction. So 20 to 30, initial velocity is 0, final velocity is negative 20. There's where the negative comes in. So we do get a displacement of negative 100 meters. And then the last interval, our initial and final velocities are both negative 20. So we get negative 600 meters there. Okay. Notice how you can only go in a straight line segment at a time. We cannot do the whole graph in one shot. Now we could have combined this section and this section because that's all one straight line, but I separate them. But remember, these equations only work for constant acceleration. So in the first interval, we have no acceleration. Then we have acceleration, then we have no, so our acceleration is changing throughout the whole 60 seconds. So we cannot do that one shot. We do have to break that up into those steps. Okay. Now, you may be already thinking this, but we just talked about how the area can get us the displacement as well. So let's look at that. We're going to break this into convenient shapes. First, 0 to 10 seconds, we have a rectangle. So that's just base times height. So 10 seconds times 20 meters per second, 200 meters. Next, we have a triangle. So that's 1/2 base times height. So we get 100 meters. Next, we have another triangle. Notice where I shaded that. Okay, remember, between the line and the x-axis. Our base is 10 seconds. Our height is, whoops, I don't have it up there yet. Our height is negative 20 meters per second. So our displacement for that interval, negative 100. And then finally, the last interval, our base is 30, our height is negative 20, so we get negative 600 meters. Exactly matches what we did on the previous slide. So when you have a velocity time graph, you can use that kinematic equation, the displacement equals average velocity times time, or you can look at the area. It's going to be the same thing. Okay. Now at this point, I can ask questions like distance 0 to 60. Okay, here we can just add everything up, ignore the negatives. 200 plus 100 plus 100 plus 600, we get 1,000 meters. And then I can ask displacement for the whole trip. Okay, displacement, direction is important, so pay attention to your positives and negatives there. So our displacement, we add them up with the negatives, we should get negative 400 meters here. So the car is moving in the positive direction, 20 meters per second, slows down at 20 seconds, reverses direction, passes where it started, and then keeps going until it hits negative 20 meters per second for the remaining time there. Okay, so we actually pass our 0 point. Now, can you figure out at what time we passed our starting point. So again, we're going 20 meters per second. We slow down at 20 seconds. We start speeding up in the other direction. We pass our starting point at some point. What time is that? I'll let you think about that one.